Hello everyone, good afternoon. Thank you so much for your time today. I'm Nitish, I'm a research engineer at Comcast, and I work on, basically I'm involved in research that aims to do create tools for security threat modeling. And today I will be talking about some of the security threats in AI ecosystem, and I will be talking about our research project called Guardrail that we have developed at Comcast. So a couple of other researchers who I'm covering for today, Nure and Jayati. And in this, what I will talk about is, I'll talk about a solution that addresses some of the security issues that typically exist or would exist within the AI applications. Thank you. So let's see the motivation first. So we have seen most of the cybersecurity applications, or some of them use deep neural networks in order to do some basically to detect the pedestrian traffic or road signals, etc. And it has been found in some of the research that just by perturbing or adding noise to the inputs, in some cases, can make the cyber physical system, or in this case, a self-driving or an autonomous car, to basically cause misclassification of the labels, as well as cause serious issues. So these kind of issues would result both in the digital and physical domain. In terms of physical domain, basically, if the adversaries add some perturbation noise to the inputs, in that case, it would be difficult for the humans to identify that a noise has been added, because it's just perturbed slightly, but it can cause the algorithm to generate a wide classification, which is totally not what the object is. So according to one of the studies, close to 72 to 85% of such situations can go undetected. So this is one of the signs wherein an easy perturbation can throw off the classification in an AI system. There is another example. So this example is with respect to supervised learning. In this, a model was trained on a clean data set. However, the adversaries, what they tried to do is they took one of the image, transformed it, or basically added some adversarial noise to it, and fed it back to the system or the model to classify. So in this case, the plain image got classified as a frog image. So this is another instance wherein some perturbation noise within the input data can cause the AI system to generate incorrect output. So after looking at some of these examples, we see that AI security is different. We need to have a different standard when it comes to evaluating the security for an AI application. So for example, I think. So one of the some of the issues for evaluating AI security is that the tests or the standards that are developed for. Okay, I think we'll wait. So basically, what I'm trying to say here is that the tests or the standards that are created for AI systems may not be comprehensive. So let's say a security standard that is designed for one AI application might not exactly apply to another type of AI application. The second test, or the second standard, the second issue with the testing and standards for AI system is that it's not concrete. So in most cases, the tests are not comprehensive. And they are not concrete, and the tests are not exhaustive. So like for traditional systems, if you have an exhaustive like testing or standard in place, that may not be the case for an AI system. The third one is the tests or standards, they lack constituent testing. So it's quite challenging to test an individual part of an AI system. Most often it is that the testing takes place at an abstract or a system level. So overall, testing AI systems is challenging, and we don't yet know how to fix them. So the bar to defend is quite high in this case, but the bar to attack is quite low, especially with the addition of LLMs. The job of the attackers is quite simple to basically scale their attack and without having to spend too much time or effort. So now, having seen some of the issues, let us see some of the two security problems with AI/ML. First one involves using AI/ML models for curating security attacks. So this is basically using some AI model to attack the other applications. And the second one is attacking AI models. In this, we are attacking the AI model itself. So today I will be focusing more on the second one, but I'll quickly cover what the first problem involves. So in this first case, this can be termed as offensive ML. So here we are applying ML to cause security problems. So these are some of the examples of problems that can cause for the system, for the AI system. One example would be like having an AI model. It can help the adversary to have faster password guessing. And the second example could be, for example, many a times the security vendors will build sandboxes within their applications in order to find out the behavior of the malware. And many of the times the adversary can use this ML model to try to find out what's the environment in which it is operating. So by using these models, the malware can decide to not behave in a malicious way if it detects that it is operating in a sandboxed environment. So these are some of the examples of basically using ML offensively. And the second one, which I will be focusing today, would be attacking like AI ML models. So in this case, this can be termed as offending ML. The CVE here that you see here, it's one of the first of its kind created for ML applications. And basically, CVE is, as we all know, it's a common vulnerabilities and exposures. It's a list publicly disclosed about cybersecurity vulnerabilities. And this CV that is listed here, what happened here was basically Proofpoint was having a solution, an AI-based solution, which identified whether an email was basically spam or was it like phishing, etc. And it also looked at what are the malicious documents included therein. In this, what it did was it tried to copycat the machine learning classification model to some extent, and tried to basically examine the output and extract insights from the original model that was used to detect the phishing emails. So this is the scope of my talk today. In this, we focus on offending AI ML systems rather than using them as an offensive attack mechanism. Let us see what are some of the generic steps that we can undertake here. The first step would be, first of all, we determine whether AI or ML solution would be required at all in the first place. Because if we don't need AI and we don't like to basically realize that particular feature, then we do not need to complicate things from the security standpoint. For example, there are more traditional security methods like firewalls or setting up access-based privileges that are usually better solutions than using AI-based trust scoring. The second one naturally is to either build our own apps or the vendor, or use a vendor to create the app. So in this case, depending on the organization's risk appetite, the organization can decide if they want to build their own AI apps or get it built by third parties. The advantage here, if the organization decides to build their own app, is they can control their own. They can basically control the security aspects of their application, and they can take the responsibility in case something goes bad. The second approach would be to have vendors creating applications for the organization. In this case, the responsibility for managing risk gets transferred to the vendor. However, it reduces the accountability of the organization in case some security incident occurs. But if an organization wants to go this route, then they need to approach it differently. They need to use a combination of models and have processes or mechanisms that oversee third-party application onboarding process, as well as the security employed by the vendors. So this is another generic way in which we can deal with the issue. The third way would be to have standards and guidelines. So standards play an important role in establishing the baseline security practices for an organization, and they promote common understanding of AI security. Just to understand why standards are important, especially for security in AI, here on the right we see a graph. So this graph talks about how the rising trend in numbers in terms of standards created for AI applications. And here, this trend is more because there are more efforts that are being made to standardize the security practices. And this increasing trend is a good and a positive sign, but just complying to standards does not mean the application is secure. So there could be some issues here because in some cases, the standards might not cover all the potential security risks present within the application, or even if the standard is there, maybe the implementation of the standard might not be correct. And with the rapid advancements within AI, there could be unforeseen security challenges that can emerge. So these are some of the things we need to keep in mind. The fourth and the final process I will talk about today would be to have a end-to-end process to secure AI ML apps. In the first phase, identify. Here, the organization can identify the applications which are AI specific within it, and once they identify the application, they can move to risk ranking the critical systems. In this, they will have a look at the different applications and determine the priority of the apps based on how much risk they carry. So the apps that process PIs would be given a higher priority, maybe as against other apps which specify web page configurations. And the third stage would be finding threats. So this is basically security threat modeling of AI applications. And I'll talk about this more further. The final step would be the verification step, wherein the organization can employ teams for performing adversarial testing, some static code analysis, red teaming, etc. So where does guardrail come into the picture? So guardrail comes into the picture in finding threats. So the guardrail can be used to do security threat modeling of AI applications. And in order to do security threat modeling of AI applications, first of all, we need to build a common AI threat library. So the goal here would be for this particular project was to figure out the unique security threats to an AI application that is undergoing the threat modeling process. Now, next we look at some of the methodology we followed in coming up with guardrail. Here, this is some of the detailed methodology that we used. In the first step, basically, what we did was we conducted a literature review to find potential threats to AI/ML applications. We looked into different digital libraries at academic sources and searched different documents and reports that came from credible sources. The second stage that we did was, after this initial literature review, we identified an initial set of libraries or frameworks that we can potentially use. However, after looking at some of these libraries, we found out that many of these libraries were using different taxonomies, or they were having some variations that were there here. So in order to basically, we needed to set a inclusion criteria on which particular libraries we should select. So we excluded those libraries which did not have content related to privacy and security, and we also excluded those which were non-application specific. So by non-application specific, I meant the libraries that talked about threats at a nation level or at a larger level than the application level. So after excluding some of these libraries, this resulted into 14 resources that we could potentially use. Here we created a unified list of all the potential threats that could be found in these 14 resources, and which gave us close to 429 threats. So we looked at these 429 threats, and some of these threats were duplicates. So we sorted them, removed the duplicates, and just kept the unique threats here. So what these threats did was they determined the attack surfaces that could exist potentially within an AI application. After we did that, we converted these threats into questions or questionnaires that the security architects can use while doing security threat modeling for the AI applications. And once these threats were transformed into questions, we basically looked at we basically had some experts evaluate our questions. In that, we tried to find out the reliability of those questions, as well as we validated some of the questions, whether they looked fine or there needs to be some change, etc. So we did 10 expert interviews, and after that, we organized the libraries. We grouped the questions into based on the application type that I will talk in the in the next slides. We grouped those questions and then tried to fine-tune some of these questions for better language and understandability. So this was the process that was followed to come up with guardrail. And in the next slide, we see how did we group those questions. So we grouped the questions into 3 categories. The first one is the baseline. So this baseline category would apply to any AI ML system. So this, if you wanted to use guardrail, so you at least need to answer this baseline set of questions. Then based on if the application is continuous learning, that is, if it is having online features which basically update the model incrementally, if the AI application is of this type, they come under continuous learning. So apart from answering the baseline questions, you also go and answer the continuous learning questions. Then the third category based on the application was user data interaction. If the application involved any user data or a user interaction, PI, etc., then on top of the first two questions, type of questions, you will also need to answer the user data interaction question. So we did this categorization of the questions, and then the resulting system looks something like this. So when the AI system comes for the threat modeling, we perform general security privacy checks here. After doing this, we evaluate the AI specific threats within the application. So this can be divided into two. One is the manual process, and the other one is the adversarial security testing part. Right now, our focus is on the blue part. So guardrail consists of the blue components shown here. The manual questionnaire part. Here, as I talked about, we divided the questions into three categories: baseline, continuous learning, and involvement, user involvement. And we further subdivided these categories based on where the threat can occur within this application. So for example, if it's like a baseline application, the threat could occur from the data modules, the model part, artifact, which is the output, and or the system infrastructure. So after doing this subdivision, we basically have a set of questions. And right now, Project Guardrail is open source, so you can have a look online, GitHub. I'll share the link later on in the presentation, wherein you can go ahead and have a look at some of these questions. So after this, so the work done so far is basically, right now we have this talk ongoing, and two of my colleagues who are basically responsible for this research, they will present at the Grace Hopper conference, and then we also plan to present at LASCON. We also got some external visibility in this. Guardrail was mentioned in the OWASP project top 10 for LM applications. It was also mentioned in the NIST AI Risk Management Framework Playbook. It is also referenced in the OECD catalog of tools and metrics for trustworthy AI, and so on. We also managed to get out a paper out of this work, as is shown below. So what's next? So what do we plan to do next? So right now, we saw that we focused on the manual part, but our next future work we will dive deep into the adversarial security testing. In order to realize this, basically we will ask our question like, what is it that we can automate? In this, we plan to review the different AI adversarial threats. We summarize and define whatever are the different adversarial AI threats available or present. Then we will review some of the tools that are available therein and find any related CVEs within it. So I mentioned about the 14 key libraries that we filtered out of. So these are the 14 libraries that we have. And so after this, so Project Guardrail is on GitHub. You can have a look at it at this link, and you can reach out to Nure, who is leading this project, at this address for more details. And after this, I'll give a quick demo of, basically it's not a demo. I'll just show how it looks. Oh yeah, I hope it's visible. Yeah. So this is the Project Guardrail that you can see on GitHub. Here it contains some of the descriptions that I talked about in this presentation, namely like the different categories that we have for the questionnaire or the questions, and the further subdivision of those categories. Then we also have a list of those 14 libraries that we use. And if you want to dive deep here, we have under assets, not under assets, under the project guardrail here, we have a list of the baseline questions that can be used for any AI application that has to be done, that has to undergo security analysis. If you have a continuous learning AI application, then these are some of the additional questions that can be asked. And finally, this one, if there exists some user data interaction within the AI application, or if it processes user data, these are a set of questions that can be asked during the threat modeling. So going back to the presentation, so I think that's all for today. Thank you so much. Please let me know if there are any questions. Thank you. Yeah, go ahead.
So I think on the verify phase, you mentioned SaaS tools and like pen testers. How do you see what do we mean? But how does the AppSec team get involved in this? What role is SaaS tools gonna play in all these like AI models and security?
In this case, the tools either if they are already existing, like we can basically use them for doing more testing, and if not, then we plan to develop some of the tools that could help us with basically do adversarial testing for those. Right now, it's still we have to kickstart the work on it, but that's the plan on it.
Thank you.
What's your favorite of those questions that you have? How many questions do you have total there?
I think we have close to 47 or so
47.
questions.
Which one gives the most, vulnerable results?
Some of the most vulnerable results would be like, so for example, one of the questions therein is what data or what PI are you processing? And then, so that leads us into another bunch of questions, which could be like, how are you basically using that PI? Are you trying to basically update your model based on that PI, or is it just for processing? So these are the, that section of the questionnaire is what I'm most interested in. Thank you. Good question.